Today in Advanced Algebra 1 we'll be solving linear equations. And the way you solve an equation is you do the order of operations backwards. The first thing you look for is you're trying to get the variable all by itself on one side of the equal sign. Well, if there's anything being added or subtracted to that, you do the opposite to both sides of the equation to keep that thing balanced. So since there's a plus 2 right there, I will subtract 2 from both sides. So we'll do that, and this x will come down. Keep your equal signs nice and lined up to where they were nice and in line. And 6 minus 2 is 4. And I have successfully gotten x all by itself. That was the goal. X equals 4 in this situation. So on this guy, here's the term with the variable in it. Is there anything being added or subtracted to it? There sure is. There is a minus 5. So to get rid of that minus 5, we do the inverse of that. A lot of people call it the opposite, but it's really called the inverse. We will add 5, but you got to do it to both sides of the equal sign to keep that thing balanced. So x comes down, equal sign comes down, and 11 plus 5 is 16. So there's our final. And then one more of those. It doesn't matter what the letter is. Most of the times it's x, but in this case it's a. There's a plus 4 hanging out with it, so we'll get rid of that plus 4 by subtracting 4 from both sides. And don't be scared. You can get negative answers in that case. So that's no big deal. And then we'll kind of step it up a little bit. Here is the term with the x with it. There is not anything being added or subtracted to that, so doing the order of operations backwards, the next thing is there anything being multiplied or divided by it? And there sure is. There is a times 6 hanging out with that guy. So to get rid of that times 6, we will divide both sides by 6 in that case. So 6 divided by 6 is 1, and the x comes down with it. And 18 divided by 6 is 3. Trying to get x all by itself, or the variable. Same thing going on here. We got 7 times y. There's not anything being added or subtracted, so to get rid of that times 7, we will divide both sides by 7. Y comes down, equals comes down, and 28 divided by 7 is the quattro. And then don't let this guy scare you right here. Yes, it is a fraction bar, but it's really divide. And what I'd like to do is get rid of that divide by 2. I get rid of divide by 2 by multiplying both sides by 2. So to multiply both sides by 2, it would look like this. The times 2 and the divide by 2 cancel each other out, and I'm left with 12 times 2 on the other side, which is 24. So all of these were one-step equations. We could do one move, and things were pretty simple. We're going to talk about show and work here. This is some stuff that we'll do at the end of the year. So if you please believe me, the work that I ask you to show, we'll do over here. So here we go. Now that they're not one-step equations, these are going to take multiple steps. So here is the term with the x with it. And I know it's got a times 2 with it, right? But you got to ask yourself, is there anything being added or subtracted to that term first? I want to get rid of it. So there is a minus 3 right there. We will get rid of that minus 3 by adding 3 to both sides. That cancels out. 2x comes down. You notice I've been moving it like close to the equal sign because I want my equal signs to line up. That's the way we'll organize stuff, and I'll get 5 plus 3, which is 8. But see, x is not all by itself. There is a times 2 hanging out with it, so I will get rid of the times 2 by dividing both sides by 2, and now I have figured out that x equals 4. So that took a couple of moves. And you do the order of operations backwards. So here is the term with the variable in it, but there is this plus 1 on the side that I don't want to be there anymore. So I'm going to get rid of the plus 1 by subtracting 1. 6w comes down, and 19 minus 1 is 18. Uh-oh, sorry about that. And then we will divide both sides by 6 to get rid of that times 6, and w equaled 3 on this. Why don't you pause the video and see if you can get number 9 done without me. So pause, give it a shot, and then hit play again. So our first move, I know it's kind of weird that the 5m is on the right side of the equation this time. Who cares? We're going to just solve for m. So there is a plus 4 hanging out with it. I will subtract 4 from both sides. And when I did that, that's what my work looked like. Now there's a times 5 hanging out with that guy. So I will divide both sides by 5 and get that. So that's what we were looking for. And then we get scary town right here. We got this little fraction. Don't worry about it. There's a plus 2 hanging out with this guy. So let's make our first move to subtract 2 from both sides. So x over 6 comes down. Negative 3 minus 2 is a minus 5. And yep, it is a fraction, but it's also a divide by 6. So we're going to get rid of a divide by 6 by multiplying both sides by 6. And that means x equals a negative 30. So just rocking and rolling here. Here's the term with the y with it. I am going to subtract 4 from both sides to move that over to the other side. 3y comes down. 17 minus 4 is, oh no, 13. And when I divide that by 3, that's not going to come out very nice. So what we'll do is we'll just, sorry, I forgot to show this. Divide by 3, divide by 3. It's not going to come out very nice, so y is going to equal 13 over 3. I do not want 4 1/3. I don't want 4.3 repeating. Leave it as an improper fraction. So if not everything comes out nice, it's going to be okay. And then the last thing here, we will subtract 11 from both sides. Negative 2x comes down. 6 minus 11 is a negative 5. And then I need to watch out. A lot of people think they should add 2 to both sides because they're like, isn't that like a minus 2? It's like, well, it's negative 2 times x. So you get rid of a times negative 2 by dividing by a negative 2. And those cancel. And then, of course, this does clean up a little bit. We're not going to put 2.5, but we're also not going to leave it a negative over a negative. A negative divided by a negative is a positive, so that fraction can simplify. Let us know if you have any questions on that. We'll be happy to help you. And then finally, we'll just do a little bit of translating. What I want you to look for is the word is. The word is translates to the equal sign, so 5 more than twice a number is 17. I always say if it's on paper, circle the word is, because anything that comes before the word is will be on the left side of the equal sign. Anything that comes after the word is will be on the right side of the equal sign. So now let's just go and translate. And of course, we got our good old friend more than, which is a backwards phrase. So 5 more than twice a number. That means we've got to do the old backwards thing on just that pink part right there. So the 5 and the twice a number switched places, but is the equal sign, and then there is a 17. So we have translated from English to math. Now let's solve. So we shall subtract 5 from both sides, and then that is a 12, and then we will divide both sides by 2. So x equals 6 on that. To do that on this last guy, 3 less than 5 times the number is 53. So anything that comes before the word is on the left side. We also have less than, which is a backwards phrase. So 5x minus 3 equals 53. And then we will solve our equation. We will add 3 to both sides. Those add up to be nothing. And that's 56. And then when I divide, 56 divided by 5 isn't going to come out nice, so we're going to leave it like that. I was helping students with their homework in class, and let's say you got an answer like this, x equals like 8 seconds, you know. It's like, dude, well, that's not, let me try something a little better than that. That was a bad example. So let's go with 16 24ths or something, you know. It's like we need to reduce that, you know, like 4 goes into each one of those numbers. So make sure you reduce your fraction. So 4 goes into 16 4 times, and then actually 8 goes into each one of those, Mr. Fawnin, still, so that would reduce to 2/3. So it's cool that I kind of didn't see it right away. I just made sure that I keep reducing that each one. So make sure you reduce your fractions on homework. And then the last one, Yolanda paid this much money for a car, which was this much less than sticker price. The bad part about this orange sentence right here is it doesn't really have the word is in it for us to find the equal sign. It's kind of hidden in the word paid. Like this is how much she paid, so $33,248 is going to equal like 1752 less than, there's a backwards phrase, the sticker price. Well, do you see how they say, hey, let X be the sticker price? So here's the sticker price, that's really X, and then we want to do 1752 less than X, so backwards phrase. And when you type this in homework, it's not actually going to want this answer. Even though this is correct, this is totally correct, they want you to have the purple stuff on the left side of the equal sign and the blue stuff on the right. And I wish the homework wasn't picky like that because both of these equations are the same thing, but this is the way the homework's going to want it. And then what we do is we add 1752 to both sides to solve. So by doing that, x equaled 35,000. Make sure you put a comma in this number because he's a large number. And your homework is just a few problems. I need you to show work on these problems, 5 through 9. You know, on the other problems, if you don't want to show work, you don't have to. But on 5, 6, 7, 8, 9, write the equation down, solve for x. I will look at work shown next time. So make sure you have that done on a piece of paper. Please let me know if you have any questions. Have a good one.